Today we're going to do concept 1 vector analysis, problem number 4. Problem number 4 reads, a ball is launched with a horizontal velocity of 6 meters per second and a vertical velocity of 4 meters per second. What was the launch velocity? How high or at what angle above the ground was the ball launched? So we're looking for two things. We're looking for the launch velocity and the angle above the ground that the ball was launched from. So let's fill in the information we know. We know the vertical and horizontal components. The vertical is about 4 meters per second, and the horizontal is 6 meters per second. So we know both velocities. And now we have to find out the launch velocity. So the launch velocity is this missing side. Since we know that the horizontal and vertical components added together make up a right triangle, we can use the Pythagorean theorem, which states a squared plus b squared equals c squared. So let's plug in those values. And then you add 16 plus 36 equals c squared. You get 52, the square root of 52. And c comes out to be 7.21 meters per second. So that's a launch velocity. Launch velocity is 7.21 meters per second. Now we know all three sides. We can use the next part of the question actually asks us what the angle was above the ground that the ball was launched from. So we're looking for this. This is theta. So now that we know three sides, we can use any of our trigonometric functions, which is SOHCAHTOA. I'm going to use cosine, which is adjacent over hypotenuse. So what I would do is, I would take the inverse of cosine because I'm trying to find theta, and take 6 meters per second divided by 7.21 meters per second. Cosine is always adjacent over hypotenuse. When we put that in our calculator, we come out to get 33.67 degrees. So this angle right here is 33.67 degrees. This is problem 4.